Okay, we're back again with some subnetting. So this time we're going to do some variable length subnetting, so a bit more challenging. So if you've not seen the fixed length subnetting video, make sure you watch that first, because otherwise this is just going to blow your mind, or you're just going to go over your head. So here's the question here. So the reason for variable length subnetting is there's different requirements per network, so it's not all the same. So for example, in this question here, this is the IP address we're given by the ISP, so 172.16.0.0 class B, and we've got 4 subnets that we're creating with different requirements. We need 200 hosts on A, 50 on B, 500 on C, and 1,000 on D. So the strategy for this is you always start with your highest amount of hosts. So I'll come back to my spreadsheet. I need remember this, whereas before we're working from left to right to draw a line, it's better recommended for going from right to left because we're identifying hosts here. So I need to go to across to the number closest to and greater than 1,000. So obviously 512 is not enough, 1,024 is fine. So I go highlight this here and just draw my line on the left hand side. Okay, so that's my line. So anything to the left's network, anything to the right is hosts. So let's just call this one host D. And the size needed is 1,000. Usable addresses. So remember, so we've got 1,024, but remember to take off 2. So it's 1,022. One's for the network and one's for the broadcast. So the addressing starting point is obviously just the question. 0, 0. The CCNA notation is /22. And the subnet mask is adding these bits together here. 252. So it's 255, 255, 252.0. Okay. What's the next stage of this? Assignable range would be 172.16.1. 0.1 to 72.16.3.254. Okay. And the broadcast is 172.16.3.255. So where I've got that from is, again, we're looking to the left of this line, and the bits it's going up in batches of 4. So the third octet, because that's what we're dealing with, the third number will be going up in ranges as 4 as you hit the network. So the next network address, I could put that in now, would be 172.16.4.0. Okay. So the next highest number is subnet host A, and we need, C, going blind, we need 500. So let's just get rid of that. And again, closest to but greater than the number of hosts that we need. So this is going to be 512 here. So the new CCNA notation, I'll put that in first, is a /23. And the usable address is 510. So it's subtracting off the host number. The subnet mask, I'm adding these together here. 254. So it's 255.255.254.0. The assignable addresses will be 172.16.4.1 to 172.16.5.254. The broadcast address 172.16.5.255. Okay, so again, where have I got that from? I'm going up on the third octet. Will be going up from my previous network in blocks of 2. So that's coming from this number here. So again, if you just want to see the assignable address range, That's our assignable addresses for this particular subnet. So on to the third one. Let's just remove our line again. So on to the third one is host A, which is 200. So I need 200. I'm going to have to go for the 256. So I will draw my line to the left of that. Okay, so in this particular one, I am going to be using a /24, and usable addresses is 254. Okay. The address, the network address, would be 172.16.60. One after the last broadcast address. The subnet mask, we just add all these together, so it should be 255, yeah. So 255.255.255.0. The assignable range is 172.16.6.1 to 172.6.255. 254. Broadcast 172.16.6.255. Okay, so again, my line is there's a 0 there, so I'm not going up in anything at this point. So I'm right on the cusp. I'm used all the bits of this third octet. Okay, so finally we're on to host B to fill into this 50 needed addresses here. And just get rid of our line. So closest is this 64. Okay, so usable addresses is 62. 172.16.7.0 is our address. So again, one after this. Our serial notation is /26. So the mask, when we're adding these two numbers together, is .192 at the end. Usable addresses will be 172.16.7.1 to 172.16.7.63. Broadcast address of 172.16.7. Sorry, that's 63 and not 62. Okay, so again, where I've got that from is these networks are going up in blocks of 64. Okay, reflecting from the subnet mask that you're using. Okay, so that's a question, quite a challenging question for variable subnetting in class B. Let's just do another one for class A. So let's just type out a question that we might get. So let's use a similar address as what we might get, and just pick up some numbers here. So 192, 35, 120, 25, and 4. So again, start with the highest number first, which is this 120. So B, and then the size needed. Usable addresses is going to be 128. So I'll draw my line here. Oops. Okay, so the first one is going to be a /25 serial notation. 120, and User addresses is 126, so it's subtracting 2 from this number here, first host number after your line. The network address is the question. New subnet mask, simply adding that, I'll add in the bits together, so it's 255.255.255.128. The assignable address range is 192.168.0.1, 192.168.0.126. The broadcast address of 192.168.0.127. And again, where I've got that number from is here. So I'm going up in networks in batches of 128. Okay, so I can fill in my next network address, 192.168.0.128. Okay. So next number down is this 35 here. So I need 35. Let's just get rid of the line. And it's going to be host A. And here we're going to have to use 64 here because 32 is not enough. Okay, so I'll draw my line. Consider notation is going to be a /26. Usable address is 62, so it's 2 minus this number here. Submask, the new subnet mask, is just simply adding these two numbers to your default. So it's 192. Assignable range, so first one for our network address. To 192.168.0.191 broadcast address, and to making that takes me 190 broadcast address. 192.168.0.191. Yeah, so again, where I've got that from, this is going up in blocks of 64. Because the number to the left of my line in the bits is 64, so that's then the network addresses are going up in blocks 64. So that's I can fill the next network address in from that information. So 192.168.0.192. So the next number is going to be this host C because it's the next one down. Okay, and I need 25. So in this scenario, I'm going to use 32 hosts. So I'm going to draw my line there. So usable addresses is 30. User notation is 27. So I'm masking within these numbers and they already default. So it's .224 at the end. Assignable addresses are 192.168.0.193 to 192.168.0.222. The broadcast address of 192.168.0.223. And in this one, the next to the left is going up in 32s from this number here. So again, with that information, I can fill in my next network address. 224. And the last one is host D, which needs 4. Now, this one gets slightly challenging because it's a bit of a trick question. So let's just get rid of that. So in this question, you've got to be clear on what the question's asking. If it's asking for hosts, then it's fine to go the route that we're going down now. If it asks for usable hosts, then you'll obviously have to use a different number because we're right on the limit here of 4. So I'm going to go on the host route, just without the word usable in. And I'll just explain that now. So I only need 4 hosts. That's what the question I'm asking. If it was 4 usable hosts, because we're subtracting 2, we'd have to shift to this number here, which would give us 6 usable hosts. So hopefully that makes sense. So usable addresses here is 2. But like I say, if the question said 4 usable hosts, you would have to go to the next subnet along. Okay, so the new CIDR notation is /30. Subnet mask, I'm adding these numbers together. So it's 252 at the end. It's 192.168.0.225 to 192.168.0.226. There. The broadcast address of 192.168.0.227. Okay, so again, where I've got that information, how I know it's going up in that range is that first number here in the bit. So it's going up in blocks of 4. So the next network will start from 168.0.228. Okay, so that's variable subnetting with 2 sample questions and answers. Give these a try. It's challenging. Practice makes perfect, and happy subnetting.